So the next organic derivative that we're going to cover are alcohols. Now, if you remember from previous video that we did, or that you watched, alcohols contain a hydroxyl functional group. And what a hydroxyl functional group is just an OH group in the organic molecule. So it comes from the word hydroxide, right? Hydroxide ions, OH minus. You just take a hydroxide ion and you're throwing it into an organic molecule. But the interesting thing about alcohols is that alcohols aren't basic in properties. They don't sit on that pH scale on the base side of things. And so they do contain this hydroxyl group though that's there, and so you need to be able to identify those as hydroxyl groups. That's what makes it an alcohol, is it has an OH in there. Now there's three types of alcohols that you need to know. We have primary, secondary, and tertiary alcohols. And the way that you identify those is like this. So I've drawn diagrams here on the board. Here's just a regular propanol type of alcohol, and propan because it's got three carbons in the parent chain. And you can see that this hydroxyl group that's attached to this carbon is attached only to one other carbon. That's what makes it a primary alcohol. So I've labeled it here on the diagram. This is the only carbon that this carbon is attached to that has the hydroxyl group on it. Secondary alcohols, again, you can see that this hydroxyl group is attached to this carbon, and this carbon is attached to two other carbons directly. And so that's what makes it a secondary alcohol. And the last kind, tertiary, is where we've got, again, this hydroxyl group attached to this carbon. This carbon is attached to, count them, 1, 2, 3 other carbon atoms within that molecule. So that makes it a tertiary alcohol. So first thing you need to be able to do is to be able to identify what are alcohols. Second, you need to be able to identify what kind of an alcohol is it, primary, secondary, or tertiary. And then the last thing you need to be able to do is obviously name them. And the way that we name these are very simple. It's very simple adjustment to the rules that we've already covered with organic molecules. And that is, you just name the parent chain as it is. So this is 3 long, so propane. And then you drop the E from that. So you can see I haven't written propane here, I just write propan. And then whatever carbon the hydroxyl group is sitting on, then I give that the number kind of at the end like I kind of did with alkenes. So this becomes propan 1 and then ol, standing for the fact that this molecule is an alcohol. All alcohols are going to end in this ol ending. And that's what makes it unique and why it's an organic derivative. Is the thing that makes it unique to the other compounds. So propan 1-ol, this one is propan 2-ol because this hydroxyl group is sitting on carbon number 2. And again, we just number these like we do regular alkyl branches. So this one I'm numbering right to left because I want the hydroxyl group to have the lowest number possible. Here, whether I number it right to left or left to right doesn't matter. The hydroxyl group is going to get the number 2. These red numbers here are not the numbering system, it's just how many carbons it's attached to, as I illustrated before. You can number these by writing in the numbers, and I didn't write the numbers in for that because I felt like it would be a little bit too cluttered. But I would number this one 1, 2, 3. I would number this one 1, 2, 3, or the other way, it doesn't matter. For this one, I'm going to number it left to right because 1, 2, the hydroxyl group is going to get carbon number 2, as well as this methyl branch right here is also going to get a number 2. If I number it right to left, then the hydroxyl and the methyl branch get a number 3, which is a higher number, and that breaks the rules. So this guy right here is 2-methyl butan, drop the E, remember, dash 2-ol. And so this 2 tells me that the hydroxyl group is sitting on carbon number 2. This 2 tells me that the hydroxyl group is sitting on carbon number 2, and this number here tells me the hydroxyl group is sitting on carbon number 1. And that's how you name alcohols. Now there's one other kind of alcohols that you need to be able to know and identify and also name, and it's these, what we call polyalcohols. And polyalcohols is just an organic alcohol that has more than one hydroxyl group in the chemical or in the molecule. And so for this one, you can see it's got 2 hydroxyl groups. And they do something a little weird here, I'm not quite sure, but the way that you name this is you don't drop the E for this one. So this is ethane. And then we say what carbons those hydroxyl groups are sitting on. In this case, it's sitting on carbon 1 and carbon 2. And so I say 1, 2, and then diol. Di meaning I've got 2 hydroxyls, and ol meaning it's an alcohol. So ethane 1, 2, diol. This one here, I've got a hydroxyl group on carbon 1, 2, and 3. So then this is propane 1, 2, 3, triol. And so that's how you name polyalcohols. So elimination reactions, there's a variety of different types of them. First kind is what we call a cracking reaction, or just cracking. Essentially, what I like to do is I like to kind of explain it as you're taking sort of a bigger molecule and you break it up into some pieces. Sometimes the pieces aren't equal in size, but it's the same as like when you crack an egg. Sometimes you get a bigger shell and a smaller shell, and it's just the way that it works. So for this example of cracking, what I've got is just sort of kind of the most basic version of what you would see. And you would just see some kind of alkane turn into some alkene, and then some pieces that have been eliminated off or taken off. And so we've got an alkane here, ethane, and then when this process occurs, usually through a catalyst of some kind, then what we're doing is we're taking off these 2 hydrogens. A double bond will then form in this location where the hydrogens were removed, and we get this, and then that piece that was taken off, which were just the 2 hydrogens, so just the element hydrogen. A little bit of a similar example where, again, we're cracking a larger molecule into 2 smaller pieces is we might have heptane here, which is 7 carbons long, reacted with hydrogen, and then you get like a break that happens right here in this spot. And so you get butane here, and you get propane here. And the reason why for the hydrogens is because you need a hydrogen to attach on the end of each of these spots so that you have a CH3 on the end instead of just a CH2. But using that hydrogen, you can crack or break that molecule into smaller pieces. So that's another kind of version of cracking. Another kind of elimination reaction is what we call a dehydration, and this is where we have an alcohol, again using a catalyst, and what's happening is we're just taking off the elements that basically make water, and water comes off of the organic molecule that we've got, creating some kind of alkene, and then obviously water is one of our products. And so you can see that happening here with ethanol. Ethanol has a hydrogen and a hydroxyl group right here. You take off the H and the OH together, they're going to form water over here together because that's a stable compound, obviously. And then we get alkene. Again, what's being eliminated off here, we have a double bond forming in that location. And with all elimination reactions, that's the common thread, is that something is being taken off, and then at the site where those atoms were stripped off, you have a double bond forming in that location to fill the octet of the atoms that had those things stripped from them. And so I've got one more example of an elimination reaction. I'll be right back. All right, so one last elimination reaction that you guys need to be aware of is this one right here. And there's no special name for this, it's just an elimination reaction. You can see that these things over here are kind of being eliminated off of this molecule here. Some things are kind of combining. What I've tried to do is I've tried to kind of color code it so you can kind of see where things are sort of moving around. Essentially what it is we have any kind of halide here, and I've got a really simple chloroethane halide molecule that's here as an example for you. Reacts with a base, and when we're talking about a base, we're just talking about it reacting with a hydroxide ion. And the reaction occurs where this chlorine and this hydrogen both come off of the molecule. This H attaches to this OH to make water, and this chlorine just comes off as an ion, just sitting there by itself as a chloride ion, halogen ion. And then what's left over again is the place that we've had things eliminated from. In between those 2 carbons, we have a double bond that's formed, and so in this case, we have just ethene that's made. So the thing to remember as it relates to elimination reactions is that what we're doing is we are just eliminating something from the major molecule that is part of the reaction. and at the place or the site of where things have been eliminated off, a double bond is going to be formed in its place, so that those octets can be filled up. So that's it for elimination reactions, guys. Thanks for watching.